Hello friends, welcome to our channel. In today's session, let us have a look on two-dimensional transformations of an object in computer graphics. So far, in the previous videos, we have learned different line drawing techniques and circle drawing technique and ellipse drawing technique. And in today's session, let us have a look on two-dimensional transformations of an object. So mainly these transformations means the manipulations done on objects. That means moving an object from one position to another position, or rotating an object with a certain angle, or resizing the object. That means maximizing the size of an object or minimizing the size of an object. That means modifying the size. So these are the basic transformations. The first one is translation. Second one, scaling. Third one, rotation. So these are the three basic transformations. So in this session, let us have a look on these three transformations, and let us see the matrix formats for these three transformations. And in the next session, we will see the examples for these three transitions. Let us start from this translation. For this translation, here the translation means moving the object from one position to another position. That means changing the position of an object. So for this change, we require two transition parameters called Tx and Ty. The name itself indicates Tx is the translation parameter with respect to x-axis, Ty the translation parameter with respect to y-axis. And coming to the scaling means resizing the object. Here also, in order to resize the object, either to maximize or minimize, we require two scaling parameters. That means denoted by Sx, Sy. So here Sx is the scaling parameter with respect to x-axis, and Sy is the scaling parameter with respect to y-axis. And in the rotation, we need an angle to rotate the object. This angle may be clockwise direction or anti-clockwise direction. So it may be clockwise or anti-clockwise, and this scaling may be maximize or minimize. Now let us have a look on each transformation, and let us derive the formula for each transformation, and let us see the matrix representation for each transformation. Let us start with the first transformation function, that is translation. So translation is changing the position. Changing the position of an object. So let us consider P x comma y is a normal point, and P dash is a x dash comma y dash, which is a new point. That means point after translation. This is a point before translation. So we require the translation parameters. So tx comma ty with respect to x axis y axis. So that the formula is x dash is equal to x plus tx. Similarly, y dash is equal to y plus tx. So this is the formula used to find the new coordinate, that means after translation x dash y dash. So this can be written as p is equal to p dash plus t, where p dash is a new point, t is a translation parameters. Sorry, p dash new point, so old point plus translation parameters. So in the matrix format, we can written as x dash y dash matrix is equal to x y old coordinates plus tx ty, or we can simply written as x dash y dash is equal to x y plus tx ty. So simply adding the translation parameter to the old coordinates, we will get the new coordinate. So if we want to translate a triangle, so a triangle, it consists of 3 points. So each and every point should be calculated for the next coordinate, translated coordinate. So let it be, if it is a triangle with A, B, C. So first consider the point A and find out the A dash, B, calculate the B dash, C, C dash. So that the object will be moved to the A dash, B dash and C dash. So this is a formula for translation. Now let us move on to the, so examples we will see in the next session. Now the second transformation is scaling. Resize the object. Scaling means resizing the object. So the size of an object may increase or it may decrease. Here also we will use two scaling factors, Sx and Sy. So in the first case, if both the scaling factors Sx and Sy are in between 0 and 1, then the point is closer to origin. That means the point will be closer to the origin. That means size will automatically decreases. The size of an object will decrease. If Sx and Sy are greater than 1, then the point is away from the origin. That means the size of an object increases. So if both the scaling parameters are greater than 1, the point is away from the origin. The scaled point is away from the origin. That means the size always increases. And if Sx and Sy are equal, so here the scaling will be done uniformly. That means that either it may increase or the size may decrease, but it will be uniformly done. Both the x and y axis will be scaled uniformly. So we have to remember these points. So in between 0 and 1 the size decreases, in between greater than 1 the size increases. If both are equal, it may increase or decrease, but the scaling will be done uniformly in both x and y directions. Here in this transformation function also, let us consider p as old coordinates x and y before scaling. So before scaling, and p dash is equal to x dash comma y dash, that is after scaling. So we have to find x dash is equal to x dash and y dash. So formula is x dash is equal to x into sy, y into sorry x into sx, y into sy. So in the translation function, we are using just addition operation. So we are adding the translation parameters to the old coordinates. Here in the scaling, we have to multiply the scaling parameters to the old coordinates so that we will get the new coordinates. So x dash is equal to x into sx. So in the matrix representations, we can write it as x dash y dash is equal to x y sx 0 0 sy. So if you multiply these two terms, x into sx plus y into 0, that is x into sx, x into 0 plus y into sx, that is y into sx. So this is the matrix representation for scaling operation. So we have to remember that based upon the scaling parameters, the size of an object may vary. If the scaling parameters, both the scaling parameters are in between 0 and 1, the size will be decreased. And if the scaling parameters are greater than 1, the size will be increased. And if both are equal, the size may increase or decrease, but it will be done in uniform. Next, let us see the third transformation function, that is rotation. So we have to rotate an object with a certain angle in either clockwise direction or anti-clockwise direction. First, let us see that. So here, like P is xy, P is a point, and we have to rotate that point through a certain angle. And this is a initial point which is having with a angle phi by default. Now we have to rotate this point with certain angle theta. Let it be. This is the P dash x dash y dash. So y dash, and this is x dash, and this is with an angle theta, and here it is radius r. Let us consider. So this is the p x comma y before rotating, and this is p dash x dash comma y dash after rotating with the theta. So with this first one, so cos phi is equal to as we know that cos theta formula, that is adjacent side by hypotenuse. Adjacent side means x by hypotenuse means r. So from this we can write x is equal to r cos phi. Similarly, sine phi is equal to opposite side by adjacent side. Opposite side is y by hypotenuse means r. So y is equal to r sine phi. So let us remember these points. Now, after rotating the point from P to P dash with an angle theta, so the new angle after rotation P to P dash is equal to phi plus theta. This is the new angle. So from this new angle, let us consider similarly cos phi plus theta is equal to similarly opposite side adjacent side, that is x dash by r, that means x dash is equal to r into cos phi plus theta. Similarly sin phi plus theta is equal to opposite side, that is y dash by r. So from this y dash is equal to r sin phi plus theta. So this is just like cos a plus b. Now let us write the formula here. Cos a plus b is equal to cos a cos b minus sin a sin b. Similarly, sin a plus b is equal to sin a cos b plus cos a sin b. So this is a formula for cos a plus b sin a plus b. Just you have to substitute. We have to expand this cos a plus b. So this can be written as x dash is equal to r cos a plus b. So r cos phi cos theta plus minus r sin phi sin theta. Similarly, so from this equations we know that r cos phi is x and y r sin phi is y, so it can be substituted here. So x cos theta minus y sin theta. So this is the formula to find x dash. Similarly, y dash is equal to r sin a plus b, that means r sin phi cos theta plus r cos phi sin theta. From this we can replace this r sin phi, r cos phi, r sin phi with y, r cos phi with x. So y cos theta plus x sin theta. So just shift this term to front. So y dash is equal to x sin theta plus y cos theta. So this is the formula to find the y coordinate, new y coordinate. Now, so what is the matrix representation for this rotation? So here we are rotating this phi to theta. That means the rotation is in this way. That means anti-clockwise. Anti-clockwise, we are rotating the point in anti-clockwise. So phi theta. So in matrix format we can write it as x dash y dash is equal to x y cos theta minus sin theta cos theta. So x dash is equal to x cos theta minus y sin theta, y dash is equal to x sin theta plus y cos theta. So this is the formula for rotating a point with a certain angle theta in anti-clockwise direction. So first we are So with, before rotating the point, we are considering cos phi. It has x is equal to r cos phi, sin phi is equal to y by r, y is equal to r sin phi. Now we are rotating the point P to P dash with an angle theta. So the new angle will be phi plus theta. So from that, cos phi plus theta is equal to x dash by r, and y, so y dash is equal to sin phi plus theta is equal to y dash by r. So here just we are expanding this cos a plus b and sin a plus b, so that we are getting x dash and y dash. So this is the matrix representation to find the x dash and y dash if the point is rotated in anti-clockwise direction. Now let us see the same in a clockwise direction. If the point P rotates in a clockwise direction, similarly, let us consider the point P, which is x comma y. So this is y, this is x coordinate, and this is phi, and this is r. Now from this one, as we know that x is equal to r cos phi, y is equal to r sin phi. So same in the as similar to the previous one. If the point is rotated, so if it is a p dash x dash comma y dash, let it be here. So this is y dash x dash. So this is a x dash, so new point with angle theta. So the new angle, so here the angle rotation is in this way, in this way. That means clockwise. New angle after rotation P to P dash. The new angle is phi minus theta. Now similarly, x dash is equal to r cos phi minus theta, y dash is equal to r sin phi minus theta. Now write down the formula. Cos a minus b is equal to cos a cos b plus sin a sin b. Similarly, sin a minus b is equal to sin a cos b minus cos a sin b. So just expand this cos a minus b. So x dash is equal to r cos phi cos theta plus r sin phi sin theta. So we can substitute x and y in place of r cos phi, r sin phi. X dash is equal to x cos theta plus y sin theta. So this is the formula to find the x coordinate, the new x coordinate. Similarly, expand this. Y dash is equal to r sin phi cos theta minus r cos phi sin theta. So replace r sin phi, r sin and r cos phi. So y dash is equal to y cos theta minus x sin theta. So this is the formula to find the y coordinate. So x dash is equal to x cos theta plus y sin theta. Y dash is equal to y cos theta minus x sin theta. So this we can write a formula, matrix format. X dash y dash is equal to x y into cos theta minus sin theta sin theta cos theta. So x cos theta plus y sin theta minus x sin theta plus y cos theta. So this is the formula to find the new coordinates after rotating with an angle, rotating the point x comma y with an angle theta in a clockwise direction. So this is the formula for clockwise. So previously we have find the formula for anti-clockwise. So just a similar way we need to follow for both the processes, clockwise and either anti-clockwise. The main difference is the new angle. So if the point is rotated in anti-clockwise direction, the new angle will be phi plus theta. And if the point is rotated in a clockwise direction, the new angle will be phi minus theta. And automatically we have to expand this cos a plus b, cos a minus b, sin a plus b and sin a minus b, so that we can get the equation for new coordinates. And let us see these examples, some examples in our next session. And let us stop here, and once again let us write all the formula in a single line. Say, so three basic transformations. One is translation. So in the translation, the formula is x dash y dash is equal to x y plus tx ty. Scaling. So this is position change. Resize. X dash y dash is equal to 0 0 x1. Rotation. So here first clockwise direction, x dash y dash is equal to x y in cos theta. Anti-clockwise, dash y dash is equal to x cos theta sin theta minus sin theta cos theta. So these are the formula just we have learned. So let us stop here in this session, and in the next session let us see a few examples for this translation, scaling and rotation through a clockwise direction and anti-clockwise direction. Hope you understood these basic transformations, and thank you.